Electrical work often requires permits, and it is important to understand when they are necessary. When working with a general contractor, typically the general contractor is responsible for obtaining the required permits. However, it is important to remember that even if the general contractor doesn't pull the permit, you as the electrical contractor could still be held liable for any penalties incurred. When dealing with the main electrical enclosure or service, permits are usually required for any work that affects the main electrical system. This includes, but is not limited to, adding or replacing service panels, rewiring an entire home, or installing a generator. If a homeowner insists on not pulling a permit, it's crucial to clearly explain to them the potential risks and liabilities involved with unpermitted work. However, ultimately, the decision rests with the homeowner. There are several specific situations where pulling a permit is generally recommended or required. Firstly, new construction or major renovations almost always require electrical permits. Secondly, adding new electrical circuits or changing the size of the electrical service necessitates a permit. Thirdly, any work that involves structural changes, such as drilling holes in walls or ceilings, may require a permit. Fourthly, replacing electrical panels, especially if the new panel has a different amperage rating than the old one, typically needs a permit. Fifthly, installing swimming pools, hot tubs, or other outdoor electrical fixtures usually requires separate permits due to the specific safety requirements involved. Sixthly, any work that involves the main electrical service, including upgrades, repairs, or replacements, will likely need a permit. The penalties for not obtaining a permit when one is required can vary depending on the specific jurisdiction. Common penalties include fines, stop work orders, requirements to obtain a permit retroactively, and additional inspections. Furthermore, not having the necessary permits can create difficulty when selling the property in the future. There are other important considerations to keep in mind regarding electrical permits. Firstly, some homeowners' insurance policies may not cover electrical work that was performed without a permit. Secondly, manufacturers may void their warranties on electrical equipment if it was not installed according to code and permitted. Safety is a paramount concern. Unpermitted electrical work can pose serious safety hazards, increasing the risk of fire, electric shock, and other dangerous situations. It is always best to err on the side of caution and obtain a permit when there is any doubt about whether one is required. Consult with your local building department or a qualified electrical inspector to determine the specific permit requirements in your area. Understanding and complying with local electrical codes and permit requirements is essential for ensuring the safety and legality of electrical work. Ignoring these requirements can lead to significant financial penalties, legal issues, and potential safety hazards. Always prioritize safety and compliance when working with electricity. When dealing with electrical systems, it's important to adhere to the National Electrical Code, or NEC. The NEC provides comprehensive standards for electrical installations to ensure safety and prevent hazards. Understanding the NEC is crucial for any electrical work, whether it requires a permit or not. Several articles within the NEC are relevant to permit requirements and safe electrical practices. NEC Article 110.3 covers examination, identification, installation, and use of equipment. This article emphasizes the importance of using equipment that is listed and labeled for its intended purpose and installed according to the manufacturer's instructions. NEC Article 230 pertains to services, which are the conductors and equipment that deliver electricity from the utility company to the building. Any work on the service, such as upgrading the service size or replacing the service panel, almost always requires a permit. NEC Article 250 deals with grounding and bonding, which are essential for preventing electrical shock hazards. Proper grounding and bonding are critical for safety and are often inspected during the permit process. NEC Article 300 covers wiring methods and materials. This article specifies the approved wiring methods for different applications and the requirements for protecting conductors from physical damage. NEC Article 310 addresses conductors for general wiring. It includes tables that specify the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. For example, NEC Table 310.16 provides ampacity ratings for conductors in raceways or cables. NEC Article 400 covers flexible cords and cables. It specifies the permitted uses and limitations of flexible cords, such as extension cords and appliance cords. NEC Article 406 pertains to receptacles, cord connectors, and attachment plugs. This article includes requirements for the type and installation of receptacles in different locations, such as ground fault circuit interrupter, or GFCI, protection in wet locations. NEC Article 408 addresses switchboards and panel boards. This article covers the construction, installation, and protection of these important components of the electrical system. NEC Article 430 deals with motors, motor circuits, and controllers. This article includes requirements for the overcurrent protection, disconnecting means, and control circuits for motors. NEC Article 440 pertains to air conditioning and refrigeration equipment. This article covers the specific electrical requirements for these types of equipment, including the sizing of conductors and overcurrent protection. NEC Article 500 through 516 cover hazardous locations, which are areas where flammable gases, vapors, or dust may be present. These articles specify the special requirements for electrical equipment and wiring in these locations. NEC Article 547 addresses agricultural buildings. This article includes requirements for wiring methods, grounding, and bonding in agricultural buildings, where there may be corrosive environments and livestock present. NEC Article 600 pertains to electric signs and outline lighting. This article covers the installation and wiring of electric signs, including the requirements for disconnecting means and overcurrent protection. NEC Article 625 addresses electric vehicle charging systems. This article includes requirements for the installation of electric vehicle supply equipment, or EVs, including the sizing of conductors and overcurrent protection. NEC Article 680 covers swimming pools, fountains, and similar installations. This article includes extensive requirements for bonding, grounding, and GFCI protection to ensure safety around these water features. When working with electrical systems, it's important to understand basic electrical concepts and calculations. Ohm's law is a fundamental principle that describes the relationship between voltage, current, and resistance. The formula for Ohm's law is volts equals amps times ohms. This formula can be used to calculate any of the three variables if the other two are known. For example, if you know the voltage and resistance of a circuit, you can calculate the current by dividing the voltage by the resistance. Power is the rate at which electrical energy is used or dissipated. The formula for power is power equals volts times amps. Power is measured in watts. For example, a 120 volt circuit with a current of 10 amps has a power of 1200 watts. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers and fuses are rated in amps, which is the maximum current they can carry without tripping or blowing. It's important to select the correct size overcurrent protection device for the circuit to prevent overheating and potential fire hazards. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Voltage drop can cause equipment to malfunction or not operate properly. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When sizing conductors, it's important to consider the ampacity of the conductor, the voltage drop, and the ambient temperature. The ampacity of a conductor is the maximum current it can carry without exceeding its temperature rating. The NEC provides tables that specify the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trap the overcurrent protection device and prevent electrical shock hazards. Bonding connects all metal parts of the electrical system together to create an equipotential plane, which minimizes the risk of electrical shock. GFCI protection is required in many locations, such as bathrooms, kitchens, and outdoor areas. A GFCI is a device that detects ground faults and quickly interrupts the circuit to prevent electrical shock. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. RFCIs are required in many locations, such as bedrooms, to protect against arc faults in branch circuits. When working with electrical systems, it's important to follow safe work practices. Always de-energize circuits before working on them. Use properly insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical systems when you are wet or standing in water. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Proper planning is crucial for any electrical project. Start by assessing the existing electrical system and determining the load requirements for the new project. Create a detailed plan that includes the location of outlets, switches, and lighting fixtures. Select the appropriate wiring methods and materials for the application. Obtain the necessary permits and inspections. Follow the NEC and local electrical codes. Test the completed electrical system to ensure that it is working properly. Document the electrical system, including the location of circuits, devices, and wiring. By following these steps, you can ensure that your electrical project is safe, efficient, and compliant with all applicable codes and regulations. Understanding the requirements for electrical permits and following safe work practices are essential for anyone working with electrical systems. By prioritizing safety and compliance, you can protect yourself and others from the hazards of electricity. Remember to consult with qualified professionals and local authorities to ensure that you are meeting all applicable requirements.